Understanding Matrix Algebra, a comprehensive guide. Hello everyone, and welcome to our English learning series. Today, we'll be diving into the fascinating world of matrix algebra. Whether you're a student, a professional, or just curious, understanding this concept is key in various fields like mathematics, engineering, and computer science. So, let's embark on this educational journey together. Matrix algebra is a branch of mathematics that deals with matrices and their operations. A matrix is a rectangular array of numbers, symbols, or expressions, arranged in rows and columns. The primary elements of matrix algebra include operations like addition, subtraction, and multiplication of matrices, as well as finding the determinant and inverse of a matrix. It's essential in solving linear equations and in various applications in physics and engineering. Every matrix consists of rows, horizontal lines, and columns, vertical lines. The size of a matrix is determined by its number of rows and columns, denoted as mxn, where m is the number of rows and n is the number of columns. Elements of a matrix are the individual values within the matrix, usually represented by letters or numbers. Addition and subtraction. Addition and subtraction of matrices are straightforward. They are performed element by element and require matrices of the same size. Example: if A and B are two matrices, then A plus B and A, B are their sum and difference, respectively. Multiplication. Multiplication is more complex. It involves multiplying rows of the first matrix with columns of the second and summing the products. The number of columns in the first matrix should match the number of rows in the second matrix for multiplication to be possible. Determinant and inverse. The determinant of a matrix is a special number that gives information about the matrix's properties, like whether it has an inverse. The inverse of a matrix A is another matrix, denoted as A(-1), that, when multiplied with A, gives the identity matrix. Matrix algebra is not just a theoretical concept. It has practical applications in various fields. In computer graphics, it's used for transformations like rotation and scaling of images. In engineering, matrices help in solving systems of linear equations, crucial for design and analysis. In economics, it's used for modeling and analyzing economic systems. Thank you for joining me in exploring matrix algebra. I hope this video has been informative and has helped demystify this important mathematical concept. If you have any questions or need further clarification, feel free to leave a comment below. Happy learning, and see you in our next video.